Hi, everyone. We're so happy to see you today. Just a couple of things to know about our today's Zoom webinar format. First of all, you won't be able to turn on your mic or camera. That's okay, but the chat is open, so feel free to say hi or drop your questions there anytime. We are recording this session. If you have any questions, post them in the chat. We'll collect them and cover as many as possible during the Q&A at the end. And the session is designed to be one way until Q&A, so you can just sit back, watch and learn, no pressure to participate on video. And that's it, super lightweight. Let's get started. But before we are waiting for everyone to join, that will be about like 2 minutes more, we will have a quick poll. So tell us in chat which of the current models is your favorite. Just drop the question in chat. Which models do you use more often? Okay, I see the answers already. Gemini, Sonnet, ChatGPT, Claude. So we basically have all the answers. Nice, nice. Okay, cool. Mm-hmm. Perfect. Thank you so much for answering. So I feel like we are going to start. And again, welcome everyone. Welcome to today's session, Ship and Production Ready AI Features. I'm excited to introduce our today's speaker. The main speaker is Ruslan Davletyan, who is the CTO of Hyperscale. Ruslan leads our product and engineering teams and has extensive experience shipping AI-driven features at scale. Today, and also my name is Maria, and I'm a content producer at Hyperscale. So today we will walk through what it really takes to move from working code to something users can depend on and improve over time. And here is a quick overview of what we'll walk through in today's session. First of all, we're going to define the right requirements for your AI feature, choosing the right model and architecture, when it actually makes sense to use RAG, and how to test your prototype before shipping, what it takes to go from prototype to deployment, and how to evaluate and monitor your feature in production, real-world metrics and examples from Hyperscale. And of course, we will finish with a Q&A session, so stay tuned for that. And yeah, Ruslan, the mic is yours, so you can probably start with the first part.
Thank you, Maria. Hi everyone again. Let's start with like basic system design for AI features. As always, as you may already know, what are the main difference of AI features? And the main challenge is that they are non-deterministic and they have non-deterministic behavior. So even if you test every case that you thought about while developing the feature, users may find another ways to use it and to break it, or also it's pretty hard to evaluate whether this feature provides like real value to users. So it's the main challenge is non-deterministic behavior. Also, that leads to high iteration costs. And yeah, because it's hard to understand how to improve these features due to this non-deterministic nature. Oh, okay. So first of all, while we're starting to work on a new AI feature, is uh, it's a good idea to gather all the requirements you have. So first of all, you have to understand, you have to have a clear understanding what problem of user are you trying to solve. Like what are the desired input output of this AI feature, what are the quality baselines and ideal quality for that feature. So for example, uh, in Hyperscale, we had a feature that translates a code from like a code snippet to a working runnable code. And we had a baseline for it, like 80% of the snippets should be runnable after using an AI for that translation. So it's a quick example. Also, what are the another characteristics of this features is speed, cost, and scale expectations, like how fast the users should get an answer from an EA, like it should be a couple of seconds, or it's some kind of background task that can run for like several minutes, and etc. For cost considerations, usually you have like some kind of budget for AI features per users, for example, a couple of dollars, like $1, $2 per user, and all AI features that you developing contributes to that budget, and you have to choose carefully which features you want to add to that budget and how many what amount of money you can use from that budget. And the final question always is, do you really need an AI here? Because in 2023 and 2024, I think many companies use AI like a hammer for every problem and without like deep considerations why you should use AI here. And like almost every product got some kind of AI assistant that answers some questions, but actually didn't provide like real value to users. So it's always great to think like, do you really need AI in that case or not? Okay, once we have all the all answers for the questions on the previous slide, we can choose our model and that we will or models that we will use for our AI feature. And basically there are three K parameters for that, like intelligence, speed, and price. Also, there are another parameters like context window parameter, but usually these three are the main one. And the main idea usually is to use the fastest and cheapest model while keeping appropriate level of intelligence required for the task. It's like rule of thumb. And I advise you to use a web resource called artificialanalysis.ai to compare different models. Here you can see a screenshot of that resource, and here we have like intelligence chart, speed chart, and price chart, so you can choose your model that's appropriate for your task. Also, on that resource, you can compare different model providers between each other, because for open source models, it is also important to choose a correct model provider, as performance may and price may vary a lot from one provider to another. For example, here you can see Llama 4 and for example, Grok has 600 tokens per second, and Google Vertex has like 127 tokens per second. So it's like huge difference. So it's worth to consider. And also, do not rely solely on intelligent index for your task and test model on your data. Here, you can see an example from Hyperscale, we had a problem with a Kotlin code because Llama 3.2 didn't know well Kotlin, and it provided users with wrong answers. So we had to change that model to GPT-4 Mini, and GPT-4 Mini knows Kotlin better, so answers improved. But intelligence level is were kind of the same, so was kind of the same. So test on your data always.
So basically, when choosing a model, it's not just about which one is smarter, but you need to balance and remember that what's acceptable for one product may be absolutely unacceptable for another, right?
Yeah, yeah.
Okay.
Okay. So the next question is, do you need RAG or retrieval augmented generation? It's a powerful tool, but not always necessary. Like, for example, if model already knows enough, you don't need RAG. But if you have some like internal data or like some contexts that are not public, you can use RAG to add that context to model answers. So answers will be more relevant for your task. And for example, we used RAG in Hyperskill for AI assistant for user-aware responses and to reference our learning content that users already passed. So that improved answers from AI assistant. So what impacts basically RAG performance? First of all, is its embedding model. You have to choose carefully embedding model as a basic LLM model and embedding model as well. So just quick reminder, what is embedding model? Embedding model like translates your text to vectors, and its core functionality of RAG that helps it to compare different text between each other. So to select correct model for your case, you can use MTEB leaderboard by Hugging Face to compare different models. Usually, you should look at like sequence length that tells us how many tokens the model can consume and compress into a single embedding, score, and like model size and price. It's kind of similar to the LLM models as well. Another parts which contributes to RAG performance are the following. Like, first of all, is chunking strategies. Is how you split your documents and translate them to embeddings. Another one is metadata. Is like what you store along with embeddings to improve quality of RAGs. Also, you can use some techniques to uh, improve further your performance, like HighKey or making summary of your documents and storing them like, near the data, batch embeddings as well, and some different query preparations like rephrasing, hide, and other approaches that will prepare questions better for uh, and make retrieval work better. To evaluate performance of your RAG, you can use different metrics. For example, RAGAS, it's a library that helps to evaluate RAGs, basically. So you can track how your performance improves or decreases over time with your changes to your approach. Yeah. Prototyping and deployment. So imagine that you choose your model, to build some architecture of your AI feature, and decide to use or not to use RAG and connect it. After that, it's usually a good idea to build some simple prototype on Hugging Face and to test it on like small amount of real users or your some beta or internal users to check whether your feature works as you expected. Like it will help you to have quick iterations and it will help to collect early user feedback. Here you can see an example of such prototypes that we used in Hyperskill. It was a feature that personalize educational content for each user, and we used Hugging Face to test it before release, and it helped us a lot to iterate over that feature before even going to integrating it to production website. So after you done with the testing your prototype, you can start and ship your feature to production. Usually AI features are shipped as microservices. In Hyperskill, we use Kubernetes for that purpose, but you can use anything as you want. Also, when you're shipping to production, do not forget to enable caching for LLM responses to reduce cost and latency. Nowadays, you can do it by using you can do it on like AI provider level, or you can use your own caching solution for that. Also in Hyperskill, we use LiteLLM to unify multiple model providers. So LiteLLM serves as kind of a proxy, and through LiteLM we connect different providers like Anthropic, OpenAI, and etc. And on another side, we call it like proxy through all these providers. It helps a lot, and also I advise you to use LangFuse for logging and tracing your LLM queries, so you can track performance of your queries, to log them, to review them later, and to improve your features. So it helps. It helps a lot. True. Here you can see an example of LiteLLM. On the screen, you can see different models that are available inside LiteLLM and their prices on the right. So it's like you have OpenAI, Anthropic, Grok, and etc. providers. And also, LiteLM will help you to monitor your spendings on different features, on different teams, and etc. Different products. Like you can separate as you want and track your spendings. Actually, LangFuse offers the same functionality, so you can choose which one you want to use. And here you can see LangFuse functionality, and main features are the traces that you can see on your screen. Unfortunately, I can't share you these details. So, but here you can basically check every request of your feature through LLM and look at messages from user, messages from LLM, check if LLM works and respond correctly, and etc. Yeah.
Okay, but before we move any further, I have a quick questions, but not for you, Ruslan, but for the audience. Have you ever used Hugging Face Space or LiteLLM in your project yet? Drop an answer to the chat, and we will see. No, not yet. Okay. So that means that it was useful, but someone knows already. Okay, very good. Not yet. No. Okay, great. So we can probably continue talking about. I see a couple of questions in chat already, but we will come back to them a little bit later.
Okay, let's move on to measuring quality impact of our AI feature. So we deployed our feature, and we want to track different metrics of that feature to understand if it works for users, how can we improve it, and etc. And usually there are three types of metrics that we use. First one is the product-related metrics. It's uh, like direct feedback from users in likes and dislikes. It's usage metrics. It's retention of feature, retention of whole product. Is it changed due to that feature or not? Another second one is the infrastructure metrics like latency, speed, failures, availability of your microservice with your AI feature, and etc. And third one is a metric that measures AI outputs or LM outputs like helpfulness, hallucinations, and overall quality. Let's talk in details about each metric and these examples. So first one is product metrics, as I said. Usually it's great to track direct feedback from user. Like, for example, we usually use likes and dislikes because it's simple for user, it's fast, and you can understand is it working for user or not. Uh, Another feature, another metrics is like overall retention, as I said, of your product. Is it increased in group of with that AI feature or not? And feature retention is like how many users return to your feature after they first time used it. And also there are different metrics that are more context related to a feature. For example, for Hyperscale Assistant, we used following metric, and it sounds like did the user solve the problem after using the AI assistant? And this metric helped us to understand whether our AI assistant working or not. But usually you should use like different metrics to counterbalance each other because uh, if we want to game that metric, we can just provide users with answer and metric with direct answer, and the metric will be 100%, I think. But we also want to provide educational value, so you have like to counterbalance this metric. Um, Infrastructure metrics usually are following, like basic service availability, for example, 99%, failures and service crashes, request duration, for example, uh, P99, like max 2 seconds per request per user, something like that. And duration of execution for different parts of the feature. If you use several AI models, LM models, you can track each part of the pipeline that is inside your feature. It depends on your feature, but you can track every part, and usually it makes sense. And you can use Sentry for tracking of all these parameters if you want. We use Sentry in Hyperscale, and it works great for us. So, and the third type of metrics is metrics that measures quality of AI outputs. We have two subtypes here: is deterministic metrics and non-deterministic metrics. And usually, if you can track if you can use deterministic metrics, it's always great because they are fully automatic. They deterministic as a definition stance. So it's really great if you can use it, but often you can't, and you have to use non-deterministic metrics. Usually it's LLM as a judge. let's dive in some examples. For example, for deterministic metrics in hyperskill, we have following examples. For example, we had a AI feature that takes a code snippet and generate arguments for it to run successfully. So basically, we can use here pretty deterministic metrics like to pass these arguments to that code and check if it runs successfully with given arguments. It's great, really great. Second example is, as I said, we had a feature that takes a code snippet and makes it runnable by wrapping in different language constructions. For example, in Java, you have a class and public static void main, and you know it. So here we have two metrics like do code compile for languages that requires compilation, and the second metric do code run successfully without any errors. So it's these metrics helps us help us to determine if feature work correctly or not. And the second one is not deterministic metrics. And here we can, for example, we usually use LM as a judge here. And for hyperskill AI assistant, we have two following example metrics. Like first one is, did AI assistant provide a direct solution rather than hints to user? And the second one is, was the AI assistant reply relevant to user questions? To track these metrics, we use LangFuse. And in LangFuse, you can set up this metrics. Basically, you can choose model that will run this metrics. Usually, it's GPT 4.1. And to improve quality of these metrics, you can use the same prompting techniques that you used to improve your feature, basically. And usually, it's a great idea to use binary classification for better results. So to ask LLM is transfer to yes or no. It's greatly improve the results. And also you have to provide full context how to measure your how to evaluate answers of another LLM to this LLM, so it will understand how to rank these answers. And as I said, yeah, LangFuse will help you to track these metrics.
Okay, and out of these three, like product, infrastructure, and AI output, which type of metric do you think is like the most important for your project right now?
Is it a question for our audience?
Yeah, no, it's
Yeah.
mostly for you, Ruslan, but if you in the audience can answer it too, we will be glad for your answers. But yeah, basically that was for you, Ruslan. I'm interested, like personal, your experience as a CDO, like what would you say, which part is like the most important?
Can you please repeat the start?
Yeah, so you showed us three different types of metrics, like product metrics, infrastructure.
Yeah, I got
yeah, and like what do you think is the most important part? Like what is the basis?
It's hard to tell, but usually product metrics are the most important. So if your feature works great, but it technically works great, but like users don't use it, or it didn't impact any product metrics like retention or money or something else, it's doesn't matter basically. Yeah, because your feature is not relevant to users, and
Okay, I
it's
see.
hard truth, but
yeah, true. Okay, thank you.
yeah.
And in chat, we see different answers to that, and someone is typing that AI outputs helps most, but which is also very interesting that we can see different metrics and all of them are kind of useful, which is obvious. Yeah.
Yeah, yeah. Here you can see an example of length use and how evaluation works. So here we use like score evaluator that answers with a number from 1 to 5 and tries to evaluate content of AI assistant. And that's basically how it looks like. And here you can check how your AI feature performs, for example. Yeah. Okay. So we
Okay,
go
yeah.
through very fast.
Yeah, we still have time for questions and answers, but first of all, we will see what we covered today. Here is a quick recap of everything that we went through in this session. So the first was how to define requirements for a real AI feature, then how to choose the right model and architecture. Then we talked about when to use and when to skip RAG and how to build and test prototype, what it takes to ship to production, and how to monitor and evaluate your system, and how we track success at hyperscale. And Ruslan showed us the real examples, which was really nice. Thank you so much for showing the real stuff. Yeah, and a couple of key takeaways from today before we wrap up. First of all, is to start small, so you don't need to build the perfect AI system from day one, and don't over engineer, so you can skip things if you don't need them. And also prototype early, test your ideas quickly and get feedback before scaling. And also, yeah, track what matters, invest in metrics and observability from the very beginning. Okay, yeah, so before we go to your questions and the answers, if you enjoyed today's sessions and feel ready to go deeper into actually building and shipping AI features, we'd love to invite you to our 10 weeks AI engineering intensive. It kicks off one of the upcoming Mondays in June. So we are just finalizing the group now. The program is designed for developers like you who want to level up and transition into AI space. So yeah, you'll work on a practical portfolio ready project. So we will not focus on any theory, but we'll focus on practice. You'll get one-to-one support from senior AI engineers and join group activities and build your professional network. Yeah, so if you're interested, you can just scan the QR code on the screen and see all the details, and make sure to use the promo code. And if you have any questions, just message us on WhatsApp. We'll be happy to see to see your questions and to answer them and to send you the full curriculum. Yeah, so that's time to answer your questions. Can we get the recording? Yeah, sure. The recording will be in our YouTube, right?
Yep, yep.
Yes. Okay. That's right. Yeah, so I will start from the very beginning with the questions, and I will read them out loud so you have the time to answer. So yeah, are there any other evaluation frameworks you tried and any trade-offs you considered before choosing RAGAS?
Mm, we chose Ragas at first and really don't iterate over. We tried several different ones, but Ragas works best for us. So we kept it for our features.
Okay, great. What is the site that compares models? Again, can you repeat the name of the
I think
yeah,
someone
someone
asked it.
sent already.
Yeah.
That was artificial analysis.ai. Yeah, right. Any other questions? We still have plenty of time for them. We will count to 3 and then yeah, and then just okay. So if
Oh.
okay, yeah. We still have some questions. Yes, do almost all major LLM models use RAG or use heavily metric training?
If I understand correctly, for example, ChatGPT application has RAG inside it, and it uses RAG. But models like reasoning models do not use RAG inside, like directly.
Okay, also there is a question about MCP. Any experience with MCP?
Yeah, we built several ones. MCP is a great protocol, I think, and it it's great because it simplifies like function calling that and provides like easier wrappers for a lot of APIs, and yeah, I think it's great, and it helps to build like autonomous agents that and integrated with a lot of services. So it's great. Yeah, we actually have Hyperskill MCP that can explain code for you. You can find it on GitHub, I think.
I also see other questions, but continuing talking about MCP, there is another one. What about MCP security issues? How did you manage that?
In Hyperskill MCP, we didn't use anything that has vulnerabilities, basically. But I agree that someone can insert malicious code in MCP and execute it on your computer. It's to mitigate that, you can run MCP in Docker, for example, like to isolate them from your environment. Yeah, and also you can check the code and of that MCP for some malicious code.
Okay, thank you so much. Couple of other questions. Other than catching in the system design, were there any other strategies that helped with latency?
Basically, you should choose a faster model if you can. So, for example, for some questions for AI assistant, we use Grok models that are really fast, and that helps to answer to user questions quickly. But if it like Kotlin related question or some like deep question, we can switch to more advanced model based on some heuristics that you have. It's not like LM based heuristics, it's deterministic heuristics usually. And to use like more advanced model, it's one of the ways to improve latency.
Great, thank you so much for your answer. And I feel like there will be the last question. Can you explain again uh, when not to use RAG?
Yeah, basically, if your task that you want, or if if LM needs additional context to answer users' questions, for example, and that context private to your data, or like model doesn't have the data yet inside, for example, some new content or something like that, you should use RAG. But if model is capable of answering users' questions without additional context, you don't need it usually. But it depends on your feature, so it really heavily depends on feature.
Okay, great. I don't see any other questions in the chat. If I'm wrong, just tell me I'm wrong and quickly quickly drop your question again. Yeah, if we don't have any other questions, that brings us to the end of today's session. Thank you all so much for being there and for staying so engaged and for answering some of our questions and for asking your questions. I hope that you're walking away with a clearer picture of what it takes to ship a real AI feature from messy prototyping all the way to structured monitoring and impact tracking. A big thanks again to Ruslan for guiding us through the technical depths and real world lessons. So yeah, wishing you all smooth shipping and AI that actually behaves. Yeah, so see you next time. Thank you all.
Bye.
Bye bye.